All right, class. We're going to continue our lessons on the internals of a transmission. We kind of talked about our different uh, types of gears and how we get gear ratios, what those gear ratios mean. Now we're going to talk about planetary gear sets. The most common gear sets in automatic transmissions. There are some different ones, and we'll talk about that in one of our last lessons in this automatic transmission transactional course. But for now, we're going to focus on planetary gear sets. All right, our objectives, learning objectives. We're going to be discussing planetary gear sets. This would be simple planetary gear sets. And then what we'd call compound planetary gear sets, and we'll discuss what each of those are and the differences. And then when we're talking about compound planetary gear sets, that's when we're going to be talking about the different types, and those are Simpson, Ravenel, and Laplétier gear sets. What each of those are and how we get those gear sets. And then we're going to talk about how power can be transferred to these planetary gear sets to get our different gear ratios. The main purpose and function, we're using planetary gear sets to obtain different gear ratios. The three main parts to a planetary gear is a sun gear. That's our center gear. Obviously, you can see why they call it the sun gear. Just like our planets, our sun is the center of our solar system with planets going around it. The sun gear is the center of our planetary gear sets. Then we have our planet carrier, and then the planet carrier we have pinion gears. Sometimes it even called the pinion carrier. And then the outside gear is the ring gear. And I'll have a picture of that, those gear sets, here in a next slide or two. How we get torque through our planetary gears is we're going to have an input, and that is the gear that's going to be driven. And it could be one of the three, depending on what clutch pack or band is applied, or roller clutch. So one of those members is going to be driven. That's going to be the input of the power coming from the engine. One of these members is going to be held. In other words, that's the reaction gear. So one is going to be driven, the other one's going to be held, and that's going to cause in turn the other member to usually rotate, which gives us the output. All right. So we have the input, that's the power coming in, and it could be one of the three. Then we can have the reaction gear, which is the member that is held. The reaction gear is the one that's being held by a clutch or band. It's not going to rotate, but it's going to help distribute the power to through the third one, and that is our output gear. And again, a simple planetary gear sets consists of one sun gear, one carrier, and one ring gear. Here is a picture. This would be a real basic planetary gear set. We have the single sun gear, we have the planet carrier with the pinion gears in it, and a ring gear on the outside of it. Planetary gear sets are able to provide obviously a neutral. If we have no input or output on the gear set, we're going to have a neutral position, which means we're not going to have any power flow through the gear set, through the transmission. We can have one or more gear reductions. We can have a direct drive. We can have a reverse, and we can have an overdrive. All this, in theory, we can have out of a single planetary, simple planetary gear set. However, in application, when we're dealing with automatic transmissions, you are essentially going to have 2 forward speeds and 1 reverse out of each planetary gear set. So if you have a 4-speed transmission, you're going to have usually at least 2 planetary gear sets. If you have a 3-speed, you're going to have at least 2 planetary gear sets. Even though there's 1 less speed, 1 planetary gear set is only going to give us 2 forward speeds and 1 reverse. Okay? Depending on the configuration, how they put these gear sets together in combination with clutch packs and bands, gives us our multiple speeds. But in many times where it says 1 or more gear reductions, one of those gear reductions that it's capable of doing isn't very useful for the transmission. Okay. So even though we can get all these out of a simple planetary gear set, when we're talking about application in an automatic transmission, you can essentially get 2 forward speeds and 1 reverse out of each planetary gear set. So this will help you in trying to think of, if we've got how many speeds in our transmissions, how many gear sets are we going to need at least for that transmission. Sometimes they'll have even more planetary gear sets in them, but they're going to need at least 1 gear set for each 2 forward speeds. Here's an example where we get maximum gear reduction in a gear set. We're using the sun gear as our input. So our power flow is coming through the sun gear. We are holding the ring gear, and then the planet carrier is our output. This is an example where we get our greatest gear reduction or our lowest gear. Okay, so essentially we're using the gear teeth of the sun gear in combination with the gear teeth of the ring gear. Now, there is a way for you to figure gear ratio in a planetary gear set, depending on teeth of the ring gear, the sun gear, and the pinion gears. We are not going to go through that in this class for the simple fact that this is not a gear ratios that we change in automatic transmissions. If we have problems with the planetary gears, that does happen, gears go bad, then we just replace the assembly and it's preset. In other words, all 4L60Es are going to have the same gear ratio. All 10R80s that we just saw in the last lesson are going to have the same gear ratio. They're set at the factory. We are not going to go in there and change those. I want you guys to see how we get the different gear ratios, but for planetary gears in an automatic transmission, we do not need to necessarily know how to figure those gear ratios. If you want to look that up and read about that, that's fine. I have no problem with it. We're just not going over it in this class. Here's an example of getting a minimum reduction. This is our torque reduction, where we have very little gear reduction or no gear reduction. Here we're using the ring gear as our input. Okay, now our input is bigger. In other words, our drive gear is bigger than our driven gear. So that's where we get our overdrive. Okay, now we're holding the sun gear, and now the planet carrier is the output. Here's just an example of getting a minimum gear reduction through a planetary gear set. See, 2 forward speeds that we're getting here. And here's how we're getting reverse. Now we are, the sun gear is our input, our drive gear. Our carrier is being held, and we're driving the ring gear. This forces the ring gear in the opposite direction that it normally would go, and that gives us our reverse. It is actually the reverse direction of what our sun gear is turning. Now that we've kind of talked about our planetary gear sets, simple planetary gear sets, how power goes through those, how we get gear reduction or torque reduction through our planetary gear sets. When we get to clutch packs and bands, we'll see how we use clutch packs and bands to grab the different gears, you might say, and we'll have ones that direct power through the gear sets, and clutches and bands that become our holding devices. So we have that reaction gear, one that doesn't rotate, and then it'll give us our output speed out of our transmission through our gear set. So now we're going to get into compound planetary gear sets. Many transmissions have compound planetary gear sets in them. The first type we're going to talk about is a Simpson gear set. And a Simpson gear set essentially uses 2 simple planetary gear sets that share a common sun gear. So you're going to have 2 ring gears, 2 planet carrier or planet pinion sets, but 1 sun gear. This setup gives us 3 forward speeds, a reverse, and obviously neutral. This was a very common gear set in 3-speed automatic transmissions. Whether you're talking about the GM Turbohydromatic 400 and the Turbohydromatic 350, the Ford C4, C6s, the Chryslers A727, A904. If you remember from our history and background of automatic transmissions, you can remember those names as your very common 3-speed automatics that you found in domestic transmissions. They would also use them in 3-speed automatics and Ford transmissions. So this was an extremely common planetary gear set that was found in transmissions in the 60s and 70s. Next is our Ravenel gear set. This has 2 sun gears, 2 planet pinion sets, and a single ring gear. So you can see the difference between that and a Simpson gear set. It has, where the Simpson gear set essentially is 2 planetary gear sets with a common sun gear, you could say the Ravenel gear set has 2 basic simple planetary gear sets with 1 ring gear. Okay, this one is capable of providing 4 forward speeds, a reverse, and neutral. These were actually common in two-speed transmissions. Your Chrysler Power Flight, if you remember that, this was one of Chrysler's first automatic transmissions. The early Ford two-speed automatics, and then the GM Power Glide. If you remember, that was an extremely popular transmission in the 50s and into the 60s, and that's still being used in racing today. And they even used it up into three-speed transmissions, both GM and Ford. And then if we just talked about the 4R70W, this is the gear set that they use in the Ford's, that overdrive. That gives them their 4 speeds out of the one compound gear sets. So this again was used in many different transmissions. Here is a picture of a Simpson gear set. As you can see, we have the one internal sun gear, the single sun gear, and then you have the 2 ring gears, 2 carrier assemblies. So 2 simple planetary gear sets linked together with a one single sun gear. And this is our Ravino gear set. As you can see, looks a little more complicated. And when you get your pinion gears, they will be usually of a different size between the 2 gear sets. But they're gonna have 2 ring gears. I mean 2 sun gears. Apologize. But then they'll have the 1 ring gear. And this is, if you're tearing apart a transmission, this will be helpful when we're looking at ring gears. I mean planetary gears, to understand the different planetary gear sets you might face when you're getting into automatic transmissions. The last compound gear set we're going to talk about is the Planetary gear set. I put that pronunciation in there because if you're like me, I think when I very first ever saw this name, I wanted to call it a Planetary set. My pronunciation is horrible, so many times I have to look up the proper pronunciation for words like that. So that's why I put that in there. We get this gear set by taking a simple planetary gear set and putting it in front of a Ravino gear set. So if you know, the Ravino will give us 4 forward speeds, and a simple planetary gear set will give us 2. That is why this is commonly used in 6-speed transmissions. Not all 6-speed transmissions, but it is definitely commonly used. A good example would be GM's 6L80E transmission. This is a 6-speed heavier duty transmission that GM has used, and I think they used it in both ASIN and ZF transmissions also. Like I said, it's not used in all 6 speeds. Some 6 speeds just use 3, or some of them use 4 different gear sets to get the 6 speeds. But if you would happen to see a Ravino gear set and a simple gear set right on top of it, you would know it would be the Planetary gear set. Now that we've kind of talked about our gear sets, and again, we could go in great detail on each transmission, and we could talk about how we get the different speeds, how we configure the different speeds of those planetary gear sets. We could go to each individual transmission and say, if we apply this clutch pack to drive this gear and we apply this band to hold this gear, we will get this speed. There are too many transmissions out there, and that would just take too long a time to try and go through each one of those combinations. My main purpose of this lesson was to familiarize you with planetary gear sets, the different types, and how they function, how we get power through the gear sets. This is how we get our different speeds. As the transmission shifts, we get another gear ratio, another speed. That was the main purpose out of this lesson. I encourage you to watch the videos that we have. It's a good way to see gear sets, actual gear sets in transmissions, and a good explanation to see how they kind of work. So again, urge you to watch all the videos that I put up, not just on planetary gear sets, but on all the transmissions. Normally in class, I would have gear sets that we could pass around, and you could actually see how holding one and turning the other, and you can see the output of the third member. But since we don't have that, that's why I encourage you to watch those videos. Now that we got done talking about our planetary gear sets, we're going to talk about how we get park in our automatic transmission. Okay, you know, in our history, we talked about how the Hydromatic that was in the 1940 Oldsmobile didn't have a park position. All our automatic transmissions and transaxles have a park position, have had that for a very long time. Ever since, I think about every transmission's probably from 60s on have had a park position in the transmission. And this mechanically locks the output shaft of the transmission from turning, or the transaxle. So if you remember, our output shaft, either rear-wheel drive or front-wheel drive, is connected through a differential through the wheels, through the drive wheels. And the park position mechanically locks that output shaft so our drive wheels do not turn. Okay. This output shaft has a large gear on it. These gears, it's called a parking gear, and they have big lugs on it that look like teeth. How we get the park is that a parking pawl, a lever with a tooth on it, is pushed up into that parking gear, notches in between the teeth on the parking gear, and locks that parking gear, the output shaft, into place. And that parking pawl is connected to the case. And we know the case is connected to the engine is connected to the car. So if we lock that output shaft to the transmission case, the parking gear, which is attached to the output shaft, to the transmission case, then it is able to lock everything into place so the vehicle does not move. Here's kind of a picture of our parking gear set up. We have the large park gear with the teeth on it, hooked to the output shaft, the little round circle all the way to your left. That is usually hooked to a shaft that when you move the shift lever, I think we talked about this when we're going through hydraulics and automatic. To kind of summarize our lesson here, we talked about how we use planetary gear sets to transmit power from the engine to the rear wheels. Okay, most transmissions and transaxles use compound planetary gear sets or a combination of compound and simple planetary gear sets. There are hybrid transmissions. Toyota is one of them that uses just one simple planetary gear set. But we'll talk about that if you take the hybrid class. We'll go into more detail on hybrid transmissions. I wanted to give you an idea of how most automatic transmissions work as far as the planetary gear sets uh, are concerned. So depending on which gear is held, which gear is turned, which gear is our reaction gear, that gives us our different gear ratios in our transmissions. And if we're using multiple planetary gear sets, they're reacting with each other to get our multiple speeds. Okay, so if we have 3 planetary gear sets in order to get a 6-speed transmission, those 3 gear sets are reacting with each other to get our different speeds. So that kind of concludes our lesson on planetary gear sets. Again, I urge you to watch the videos. This will help you understand it, see what they actually look like. And then our next lesson, we'll be talking about multi-disc clutch packs and bands, how we use those to help transfer the power through the gear sets.